You know, this is funny. I just got off with a guy from England, and we're going to be doing some interesting things together. And he is a newbie to my research. He saw something I was doing not related to this and was intrigued and got a hold of me. And then as he did, I thought he was going to be talking about mud fossils, which he did. And I said, do you know about the mud fossils? He said, no. I said, you're kidding me? He said, no, never heard of it. So I said, all right, let's do the thing about the mud fossils. Forget the other thing for now. So we spent a couple of hours, and he was just like floored. I mean, you can't help it. And the first thing when I said to him, I said, you know, the guy from Johns Hopkins is saying that this is nanospheres, and they're not related. It's not related to blood, I believe, is his claims. I don't know for sure, but I can tell you right now, my claim is that is red blood from arteries. This black layer is vein blood, which is, in my world, red is hematite, black is magnetite. It's supposed to be in a crystal shape to be considered hematite and magnetite. I don't care. The red is from arteries. The black is from veins. Arteries, I'm calling hematite, it's red. Veins, I'm calling magnetite, it's black, and it's hard. This almost never hardens up. It's just you rehydrate it and it just runs right out. And it's been pouring out of there since they discovered this in 1911, I believe. You know, I got to be honest with you, I never had so much fun in my whole life as working with Guy, because he had no idea about this. I just laid it on him like I just hosed him down. I went from stuff like this that shows all the layers, and I was showing him my stuff that has all the layers in it too. You know, there's nothing I showed him that I couldn't stand behind. That's the key. If you say, oh, this happened and that happened, yada, 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 well, you don't have any evidence, well, who cares? And then I started showing him about 67P boiling off barbecue smoke in space. Astronauts say it smells like steak out there when they do their spacewalks, and it's a hip. It's a hip in space. There it is right there. It's a broken hip. There it is right here. And it broke off right here. And these things, and the heart is out there, which is Bennu, actually. They have brought the pieces back. I don't know if I told you about this yet or not, but I've been talking about Bennu. I'm going to keep talking forever because the parts are back here on Earth. Here they are right here. This is what they went down and grabbed. That's muscle sarcomeres. These are membranes. That they found the DNA, the RNA, the uracil, the chemistry, bundles of fibers right there, which is muscle fiber. It's undeniable, and there it is right there, and it is a heart, and there's the valves of the heart, and they went down inside, just blew a whole batch of stuff away, grabbed the muscle, back to Earth, and they've been almost 2 years now looking at it, and I've been screaming, it's all heart. You saw what I just showed you here. Sarcomeres from a heart, layered with phosphates. Well, guess what? Here's another heart with sarcomeres, layered with phosphates from a heart. Same thing. No difference whatsoever. There's zero difference. You see it? Boom. Boom. Same thing. And they found all the DNA, the RNA, the everything, but they just can't get their mind around the fact it could be a heart this big. And this is even big. That's only a third of a mile. You say, a third of a mile? Oh my goodness. Well, guess what? This one's 140 miles wide. 140 miles. That, my friends, is not a crater. That is a tube. That, my friends, is not a crater. That is a tube. Most of these little pock marks are not impacts. Most of those are pops. because the blood that was right under them that serviced the muscle, which it takes a ton of blood, boiled and popped out where it was right at the surface, and they're all over the surface. You see the difference in colors? You see the difference in colors up here? That's blood. Red, yellow, black. Black is when it's deoxygenated. Yellow is in the transition. Red is when it's ready to go back to work. These are the valves. One comes in, one goes out. And then there's another couple major tubing spots and so forth. And this is the tendon. And this is psyche, and they know about this, and they want to exploit it because they know it's saturated with metals. And I agree with that, because blood is primarily transition metals. That's what blood is. It's just saturated with metals. And that's why those little red blood cells are what Ken Livy said was amorphous. Oh, by the way, I don't know if I mentioned to you, I just got an email back from him, and I think he's dismissing this. I think maybe I already mentioned this to you, but I think he's sort of dismissing this, and I still want to talk because I have the evidence to support what I'm saying. Those blood cells being amorphous is exactly what you would expect, because they have the chemistry of biology inside them, just as he said in his article, which I did read, and I read it quite clearly. And in this article, he says that they were amorphous nanospheres. Now, a nanosphere is a tiny, tiny round sphere. And amorphous means it's not crystal. It's not like a ruby or, it's not like a gemstone, think of it that way. It's a conglomeration of stuff, which it is. That's what's in these blood cells. And now I show this, the hip is in space, 67P, they landed on there, they did the test. It's nothing more than barbecue smoke, and I'm not kidding you. It's exactly what it is, and it is enormous, just as 67P is. I mean, just as Bennu, Psyche, all the rest of them, gigantic. What they're doing in space, I don't know. But if they landed on Raleigh, North Carolina, it would not be a good day to be at Raleigh. That's Raleigh, North Carolina. This is 67P. That vein, that artery that I showed before, that's squirting out into space, that's an artery. It's cooking inside as the sun hits it in exactly the correct angle. Out into space it goes, barbecue smoke. These are little bitty blood vessels. I showed you how many blood vessels are in a creature's body. These are the little ones. That is one of the big ones. And the sun has to hit it just exactly the right way, and then they squirt right out of little tubes, whichever direction they're running at. And that is a hip in space. How it got there, they talk about battles in the heavens. Well, could be. You can't deny that. This is 40 millimeters wide. There's 4 of them in here. That's 500 feet, that one particular artery, 500 feet. The one I showed you in the fish, that one single one, was 1,000 feet. It's twice as wide as this. We live in a completely different world than we thought we did. So what am I saying is happening here? These are the red blood cells that turn extremely red and round and amorphous, which means they had already had all this extra little calcium and iron. They had iron is the red, but the calcium, sodium, all of that stuff, aluminum, which is the chemistry of our body fluids. It's the exact same thing. So coming out of here, they turn round and red as can be. The black, you see how hard looking that is? That's the characteristic signature of the black vein blood and the red not vein blood. They don't like each other. They stay away from each other. They will not mix. There's a polar opposites there. And the red virtually never gets solid. It's almost always easily hydrated. And I have done it many, many times. And the blood just stays red and wet. I could make something turn red here. As a matter of fact, I will do it for you. Hold on, let me find something here. All right, this right here. Right there is a layer in, just like this. Black and red is sitting on top of it. Black and red is sitting on top. I'm going to put a little water on the red, and it will hydrate just like that. It won't run quite that much, but it certainly will turn red. Are you ready, my friends? This is what we're talking about. Okay, watch this. You see that? Instantly turns red because it was saturated with blood. You see? And the black part is right up there. They don't mix. It's the same stuff as that. You see how red that turns so quickly? That's what I call it, hematite and magnetite. That may not be the technical correct term, but it's what works for me, because this is the hematite red. This is the magnetite black. This turns hard and crisp. Nothing grows. That stays fluid, infiltrates plants, makes things grow green like crazy. And when it's dead, it turns extremely red and round, tiny, tiny balls. Now, as I go back through the years, like 15 years ago, I was doing this, and I was contacting people, going back and forth about these discoveries I was making, and there was very little interaction. But I did have some, and I could sense they understood, but they really couldn't discuss. Being in, the work environment. Basically, that's true. You're in a work environment. I don't care what you did. They're going to see you as an idiot, and they're going to put you down in the idiot realm if you start talking about this stuff. And I'm telling you, that's just a fact. That's how it was. It has changed. And the people that I was talking to 15 years ago have now gotten out of that realm of suppression, and they can talk, and they are talking. And I got a couple of, I got a whole crew of them going now. And better than that, I have a whole lot of subscribers, but I don't get much interaction. There's a couple of thousand that are deeply, deeply invested in trying to understand this. And that is a lot. Trust me, that's a lot for them to follow me through this excruciating journey. It's been a long thing, and somebody to spend this much time has to really want to understand and learn. And if I'm wrong, let's talk about it. If I'm right, well, then it leads us into a whole nother realm of things, which it has. This zero that I thought was true is true. And I think I can show why I'm saying it's not true. And I show the light research, I show everything. I don't know how this all fell on me, it did. That's a whole nother issue. But we are where we are, and this is something that should not be denied, and it cannot be denied. It can only be dismissed. So I'm going to be doing a bunch of interviews. I've got a bunch of people that are talking now. I got all kinds of things going on, and I want you guys to be interested too, and start talking to people, because you have every right to talk, every right to talk. All right, and you have an obligation to talk. If you think this is true and you're in a world of untruth, it is your obligation to confront that untruth. It's your obligation. It's not just something you could do. No, it's your obligation. All right, I'm going to leave it at that. I love you all. Do what you're supposed to do. Don't let this continue. We need to find out, where did we come from? What is this doing in space? How did this happen? What did these ancient texts say? Where are we now? Who's in charge? If these gods are immortal, where are they? If they're immortal, why are these bodies laying all over the earth? These are the things you have to confront. If they're immortal, what are these body parts doing in space? A hip, some hearts. Umao is a finger. I'm not kidding you. I've looked at them all. I've looked at them all. Oh, I want to show you one last thing. How they can, anybody has any meteorites that are iron meteorites, cut them in half and see what you see in the inside. I'll show you what you see. This is what you see if you cut an iron meteorite open. You see it's nice in all these different metals because those are from blood. And that is the red blood. And that's the vein blood, the artery, the black blood. I've shown this over and over. And if you have meteorites, cut them open, this is what you're going to find. And if you look real close, there it is right there. Red blood. There's nobody can miss that. And what is it doing in the middle there? And why would that black blood, which is the iron, a vein blood, be there? And why does it travel down the side? The red. And why does this one travel down the side, the black? That's because those are where the veins and the arteries came in to feed them. These are called a digital terminus. It could be a fingertip or a toe, or it could actually be a lung or a heart. But there's blood supplies come in and go out. Artery and vein. There it is. Inside of an iron meteorite. No reason for that other than that it is blood. You see this? Chondrules, these little round balls, they're everywhere because those are the little anchors I showed you, the little skin anthesis. And here they're saying the oldest solid material in the solar system. Where did they come up with that? That black here is vein blood. This is artery blood. This is just artery. And these chondrules are those little anchor balls everywhere. They just don't understand this stuff at all. Just not at all. Wait do you see this? I thought this was hysterical. This is a bone head. Now, those two little holes there connect either blood vessels or nerves or whatever, but they're right there, right at the end of the head of the bone, and it goes out to the next bone, and it wraps around to that bone. This is some kind of a thing like this, a wrist bone or something. It connects to another bone and they rock together and do this kind of stuff. Now, where do you see this? This is from NASA. Meteorite. You see that? Meteorite. That's this. You see the dot there and the dot there that's filled with blood? It's this right here. You see it? There's the back of it right there. And here's the front coming up. And there's the two dots right there. And that's a bonehead from some other boneheads. Isn't that something? Amazing. All right. This is blood in a living creature. It's in transition stages of having a lot of oxygen and no oxygen and minerals and metals and all kinds of things going on in there. When you're dead, it pretty much just absorbs a ton of oxygen, turns into little round balls. And they have different contents, different sizes. You see how that big black wall around there, there's another one there with a core in the center. They're not all the same. But they are blood cells, and depending upon what they've bumped into or what organ they've come from, they can be all kinds of different sizes, different oxygenation states. In the lung, you're going to have all kinds of different things. Okay, this is amorphous, which means it has all kinds of different things in there, in the blood, which is what we have in our blood. It's the exact same metals and minerals and so forth. And it just sucks in oxygen, because it gets exposed to oxygen, and blood wants to have oxygen attached to it, the red blood. So the first thing you say is, this has been doing this since 1911. I say, yes. That's the claim, and I believe that's not a big deal. And you say, oh, come on, how could something with blood in it bleed for over 100 years like this? And I said, because the things that had the blood in them were so big, they had a lot of blood. I'm going to show you a creature that could easily do this for at least 1,000 years, minimum. Okay, I have made my case extremely well, if I don't say so myself, and I just happen to do say so myself. And this is dead red blood cells, and they turn round and into nanospheres, and as I think I've shown you this, they have different concentrations. They're not all the same. They varied. It's just identical to what he says. Identical. Now, I would hope, as a scientist, Ken will reevaluate his position. He said, you know, it sounded to me like he didn't want to get involved in discussing this. I could be wrong, but I just got it, and he was kind of brief, and he said, if you read the article, you would see that it was amorphous. They're not crystalline. I never said they were crystalline. I gave them a name, hematite and magnetite, and I apologize. I said, my error. They are clearly not crystalline, and they are nanospheres, and they are amorphous, and they have all of the same minerals and metals in them that he was talking about. So I think, as a scientist, even though this is spectacular, you would call this crazy. You'd say, how can anybody believe this? But when you see the evidence, you have to at least examine what you're looking at. If you don't, you're not a scientist. And I'm saying that is a hip joint. And if you look at, I have shown this to many, many, many people, and I have my friend, he's a guy I knew years and years ago, Pierre, and I'm just getting back in touch with him. I haven't even talked to him hardly. He went into astrobiology, University of Manchester, University of Arizona, and he took all kinds of courses about, you know, how biology relates to the Earth. I believe we talked just briefly. He ended up going into 15 different courses. I went into a whole batch too. I can't remember how many, but I did a bunch of them. And I did them for, you know, genomics, and I went to the University of Geneva for particle physics and a bunch of other stuff. But all I wanted to do was go there so I could interface with the professors, and it never worked out well. As a matter of fact, I went to Johns Hopkins. This is from Johns Hopkins. Oh, not this. The claim about this. This is from Johns Hopkins. See? Johns Hopkins. That's where Ken Levy is. Now, I really want to engage with him, because this is crazy to just turn away from something because it's too spectacular. I admit it is just crazy, but if something is true and there's evidence to support it, it has to be examined, and then at that point, determination can be made. But when I see we spent billions and billions of dollars to go out to pick up this sample right here, and this is what it is heart sarcomeres. And not only is it here, not only is it there, it's up on Mars, it's everywhere. There is nothing but biology. There is nothing but biology that I can find. All this stuff coming through space, it's got blood in it. Look at this. This is iron meteorite. Red blood in there. And there's the black, which is the vein blood. I call it hematite and magnetite. You call it anything you want. And I know it's amorphous, it's not crystalline, but it could be. It could be turned crystalline, because all gemstones, this is my other claim, all gemstones, all of them basically, except carbon, a diamond, and there's a couple other ones, ruby or something, I forget. There's a couple of other are carborundum, basically. They're not silicates. But all the rest of them are transition metal silicates, basically. Primarily. I can't say all of them, but I would say almost all of them. Okay, I'm always talking about transition metals. And these are transition metals. And they make all these different colors. And they have these different charges. And they can go through the membranes and find somebody that wants these charges and attach to them and become stable. And they can do that in a heart. You want to see what happens to a heart when it absorbs exactly the colors, which are frequencies, that they want to become attached to. It does this. That's an opal heart. All right, cut right across. This is the chamber of the heart. These little colors are transition metals, just like I just showed you a minute, all those colors. They're in the blood. This was tipped this way, and that's the plasma at the top. The metals are a little heavier, they drift to the bottom. The addition, you see this color all around here? That's the ventricle walls. And these are the heartstrings. And these are the plumbing that runs through, and the valves and all of that stuff. Now I have a couple of hearts here. I have a whole batch of them, but I got two of them that have actually turned to crystal. And I'll show you those uno momento. Now, look at what you're looking at though. This one still has a little bit of the muscle around the outside. A lot of that's gone, but there's still some. These are the chambers. These are the heartstrings, valves, so forth. That is what a heart looks like. Now let me show you a heart from, I think it's probably a heart attack victim, but they were putting a wire in it. Here it is right here. You see the wire? Now, what do you see here? That's the ventricle wall. Heavy, heavy, heavy duty. These are tendinous strings, and these are what they call the heartstrings. And they come down to a bunch of webbing, and that's what does this. And very, very heavy wall. And then it plumps out and comes back in, out and in, that type of thing. And this, I don't know what they did here, but probably a pacemaker or something. Now, I have two hearts here. This one here is basically the reverse of this one. So this two here is actually over here. All right, this ventricle wall here is that ventricle wall. You see it coming down here? And this, okay, the thing just crashed out on me, so, and I'm not sure where I was when it crashed. So I'm starting over again. I'm going to back up a little bit, I think. So I believe I showed you the heart. This is an autopsy, and this is the ventricle wall. And this is where all the plumbing is at the top. When they actually separate, they separate right across this line right here. And you can see right down into the valves. And that stuff just goes away because it's just basically glued on the top with a red layer and a black layer. And they separate. They don't want to be apart, and they really just pop apart. And I've had guys that do autopsies and do research, and they say that when the cadavers, if they've been stored a little while, they just fall apart. Now these are the heartstrings, the valves, the ventricle walls, and this, I have a heart right here. I think maybe I showed you, maybe not. This one here is almost completely silicates. There's a little bit of red blood left here where there was some plumbing. This is that. So it's basically turned around, that type of thing. This right here is the ventricle wall. Very heavy duty. And all of this stuff is muscle, but it's eroded quite a bit. And then at the bottom, they all have like a little gnarly thing at the bottom. I have another one that I cut open, another crystal one, just like this. The other one, though, did the break. It came broken. And then I cut it just to see the heartstrings and all that stuff. Inside here is the same thing that's in here. The collagen fibers don't change the way the tissues and fluids do. The tissues and fluids, the muscle and all that stuff, and the bone and all that kind of stuff turns into mudstone. Tendons are a little different. They don't absorb because they don't absorb in life. You see that? They're always that color because they don't want any blood inside of them. I'll show you the one that I have here. This one here I cut. And it's got all the fibers in there, same as that. But this one here, you see the bottoms are the same. You see the bottom is basically the same. Alright, but this one here, all the top stuff popped off, it basically, and then I just cut it to see the heartstrings and all that architecture inside. And you see how the ventricle wall is wrapping around? That's the same thing here, only this is like supposed to be this way. And here's all this. You know, you can almost see it almost looks identical to that. Look at that. Look at that. How crazy is that? Hold on one second. Now, this right here is quartzite, which is nothing more than blood cells, but they were boiled and washed out of all the iron and all that stuff, and left with the membrane shells around it, and filled back in with quartz crystals. And there's some different transition metals in here, yes. Primarily, though, it filled in with quartz, but they're still in these little nanospheres. That's because they were still red blood cells. That's what almost all sand is: eroded skin and blood cells.